Okay, guys, so today we are doing 2.2, which is inductive and deductive reasoning. So let's go ahead and get started where we can get these notes knocked out. All right, so inductive reasoning. What is inductive reasoning? Inductive reasoning uses specific examples to come up with a prediction. So to predict what comes next by looking at a pattern. So you want to think about patterns here. So you want to think about patterns. So for example, 4, 8, 12, 16. So what do you think the next number is? I hope you said 20 because they're increasing by 4, which is the pattern. So we predicted 20 based on the previous. What about 20? 15, 11, 8. What do you think the next number is? What if I told you that it is 6? Well, how do you get 6? Well, if I go from 20 to 15, I subtracted 5. To go from 15 to 11, I subtracted 4. To go from 11 to 8, I subtracted 3. So notice I'm subtracting 1 less each time. So that means to go from 8 to 6, I would subtract 2. So my pattern was to subtract 1 less. If I wanted to go one more number here, then I would, if I subtracted 5, 4, 3, 2, then I would only subtract 1. So my next number would be 5. So what about Monday, Tuesday? What day comes next? Wednesday. Because the pattern is going in order on this one. Now, deductive reasoning is a little bit different. So here we're looking at patterns. When you're using deductive reasoning, you're going to use facts, rules, definitions, properties, all to reach a logical conclusion. All to reach a logical conclusion, okay? So here we're going to use patterns. Here we're using facts. So for example, on Friday, we eat pizza. This is a fact. On Fridays, we eat pizza. Guess what? Today is Friday. So what does that mean? That means I can conclude that today we will eat pizza. Okay, so you're making a logical conclusion based on a fact. So the fact is we eat pizza on Fridays. Therefore, since today is Friday, we will eat pizza. So, a conjecture. What is a conjecture? A conjecture is an educated guess based on known information. So you're going to guess something based on things you know. So if I told you I needed you to make a conjecture based on the following information. Point B is between A and C. So what does that look like? Well, I'm going to come over here. I'm just going to draw it. Point B is between. So if it's between A and C, then I'm just going to put a point B somewhere between. Who cares where? Now, it says point B is equal to distance to A and C. So now what does that mean? That means I'm going to have to take, well, I thought it was going to let me move it, but it's not going to. So we'll just back up. So if it's equal distance, now it's not just between, it's equal distance, means that now it's a midpoint. Okay, so when it was just between, it was just between. But because it's equal distance, that means point B is the midpoint. Okay, and I'm making that conclusion, that conjecture, based on what I know about a midpoint. I know that a midpoint is the same distance from both ends. Now, a counterexample is a statement that you make when you want someone's statement to be false. For example, what is a counterexample for this following statement? Provide an answer and a picture. So let me just give you a non-math one real quick. If I were to tell you all birds can fly, can you prove that my statement is false? you would provide a counterexample, and you would probably say, penguins don't fly. And I would say, you're absolutely right. Therefore, you just proved by using a counterexample that my statement is false. So here we're going to try it again. Any two lines are always parallel. So any two lines are always parallel. Well, this is false. And since I'm telling that it's false, I have to provide a counter. So my counter is two lines can be perpendicular. Two lines can be perpendicular. Now it says to provide a written answer. Boom, there's my written answer. And a picture. Well, if I'm going to draw a picture of that scenario, then maybe I should draw two lines that are perpendicular, like the X and Y axis. They're not always parallel. They are perpendicular. So a counterexample, it's extremely important to understand a counterexample. You want to prove that whatever someone is saying is not true, provide a counter. All right, now we have two different types of reasoning. Okay, so two different types of deductive reasoning. So we have inductive reasoning, which uses patterns. We have deductive reasoning, which uses facts. And there are two types of deductive reasoning. We have the law of detachment, and we have the law of syllogism. Syllogism. All right. The law of detachment states, if P, then Q is true, and P is true. So if my hypothesis is true, then my conclusion will also be true. For example, if it is raining, if it's raining, if that is a true statement, then it's wet. Okay? On Thursday, it was raining. The conclusion, therefore, it was wet on Thursday. So if it is raining, okay, then it's wet. So that if P, then Q is true. So if P, then Q, this is a true statement. Now, if P is true, on Thursday it was raining. So this is the P part. Okay, this is your hypothesis. On Thursday it was raining. Then I can conclude that on Thursday, since it was raining, then it was wet. Okay, so if your conditional statement is a true statement and your hypothesis is true, then your conclusion will also be true. Okay, so let's use the law of detachment to determine this conclusion. All right, and just go ahead and move this little angle symbol up here. I don't know why it got dropped down there, but if you will please draw that right there. So we're going to determine a conclusion here. So our conditional statement says, if the measure of an angle is greater than 90, then it is obtuse. Okay, that is a true statement. So if a measure is greater than 90, we know it's an obtuse angle. I am telling you, hey, this angle right here, it's greater than 90. What can you conclude? Well, if this angle is greater than 90, then we know that this angle is obtuse. So we would say the conclusion is that angle ABC is obtuse. This is a true statement. That's true. Therefore, this is also true. Okay? So you basically take a very general statement and make it specific. Okay? We will practice more of this in class. Just make sure that you're paying attention and writing down everything that you can. Make sure you put stars by things you need more help on. Okay? If something is confusing, make sure that you're putting a star by it so we can go over it in class. All right, here's our last part. This is the law of syllogism. The law of syllogism is very easy. They're saying if I have two statements, okay, if P then Q and Q then R, notice there's two Q's, then P then R. Okay, so if this hypothesis leads to this conclusion, and that conclusion leads to another conclusion, then that means the beginning hypothesis will end the same way, in the same conclusion. So for example, if you are a ballet dancer, so I'm going to do this kind of color coding. So if you are a ballet dancer, then you like classical music. If you like classical music, see how these are the same? Then you enjoy the opera. The conclusion, if you are a ballet dancer, then you like classical music. Or sorry, then you enjoy the opera. So if you're a ballet dancer, then you like classical music. Well, if you like classical music, then you enjoy the opera. Therefore, if you're a ballet dancer, then you enjoy the opera. It's like taking the middle guy, and we're just going to get rid of it altogether. We're going to create a sentence with the beginning and the end of those two statements. So, use the law of syllogism to determine the conclusion. So let's color code it because it's easier that way. So starting with, if two lines are perpendicular, then they form a right angle. If a right angle is formed, then the measure is 90 degrees. What can we conclude? We can conclude if two lines are perpendicular, then the measure is 90 degrees. So if two lines are perpendicular, then the measure is 90. Then the measure is 90 degrees. And that's all you have to do, is you look and match. If this conclusion matches this hypothesis, then your sentence is going to be what's left over. So if two lines are perpendicular, then the measure is 90 degrees. End of story. So make sure you start everything that is confusing so that we can go over it in more detail when you get to class, and I will see you guys then. Bye.